Hello, this is Mr. Stewart from Foster Woods Intermediate School, 7th grade math. I was just put in charge of taking care of the 2.3 subtracting rational numbers video, and it's actually, there's a lot of stuff involved with this, and so instead of picking a whole bunch of different videos that covered a whole bunch of different things, I decided to do an introduction video myself. This information comes from your online textbook, which all of you should have access to, but we'll provide a link to this chapter as a PDF in the same discussion that you're watching this video. So this is all about subtracting rational numbers, and I think the big idea with subtracting rational numbers is you need to make the connection between how you learned how to subtract integers and how that connects to subtracting rational numbers. So as you're looking at this example right here, okay, what is a negative 1 1/2 and a negative 1/2? How does that look like on a number line? Well, if you look at this, you always start at 0, even if you're working with rational numbers, and rational numbers still just follow the same patterns as integers do. But notice this is saying, okay, this is a negative 1 1/2, negative 1 1/2. So really, you're just moving, instead of a whole number, a whole integer, one way or the other, you're moving rational numbers. You're moving a negative 1 1/2 in that direction, in the negative direction. And then, as you look at the next one, a negative 1/2, that's the second term. That's continuing down the path, 1/2 of a whole number, and you're landing on negative 2. So there's a lot of connection to be made with rational numbers and integers. In fact, you can think of all of the same rules or the same ideas that you discovered as far as subtracting integers goes. It's the same thing as subtracting rational numbers. I'm going to move down to the next page, and that's what this is looking at here. Is you look at the number line. This is saying, okay, you got negative 3 and a positive 2 on the number line, and find what is a negative 3 and a negative 2. What does that look like? I'll highlight that. What is a negative 3 and a negative 2? So you think, okay, go negative 3, 1, 2, 3, and then a negative 2, 1, 2. That's just the direction on the number line. Or here's another example. What happens when you do a positive 2 and the opposite of a negative 3? A positive 2 and the opposite of negative 3. Well, that's a positive 2, and then 1, 2, 3. The opposite of negative 3 is a positive 3. So really, is it any different than looking at, for example, at B here, plot 3/4 and 1 on a number line? Or in other words, what's 3/4? Find 3/4, which is going to be, so 1, 2, 3 out of the 4 whole. So this is 1 whole, and I'm landing on 3/4 here. So 3/4. Okay, and this is a positive number, so I'm going in the positive direction. And then it says go a negative 1 from there. Well, a negative 1 from that point is just going to be 1 whole. So I'm actually landing right here at negative 1/4. Okay, so the idea behind that is that you need to understand the big idea with rational numbers is understanding what fractions are versus whole numbers. Okay, so I'm going to take that. Now, this is your activity, and I'd like you to use a calculator for this. And don't forget that rational numbers are fractions, integers, and decimals. So don't forget that a rational number can be a fraction like we were working on before. 3/4 is an example of a rational number. But 75 1/100 is also an example of a rational number. And also, by the way, just another example, 6. 6 is an example of a rational number. This is also an integer. These two at the top are not integers. They are just rational numbers. But all three of these examples are examples of rational numbers. 6 can be thought of as a rational number. The reason why is because 6 over 1, here's your two integers or two whole numbers over numerator and denominator, and this is now a fraction, but 6 over 1 is just equal to 6. So we say every integer is the same, is a rational number. Okay, but not every rational number is an integer. Okay, so if I confused you too much, I apologize for that, but the task you're going to be looking at is, I want you to look at this budget here. You're starting with $100 in your bank account, which is an integer, by the way, but it is also a rational number. So you got $100. Remember that each negative is represented in red, and each positive is represented in black. Okay, so as you go through this, my question to you is, what is the total balance? What's the total at the end? Okay. And I think the way I think of this is you're going to write down into the balance side whatever's left over. So if I was doing this, I'll do the first two just so you understand. You start with $100, and I'm typing $100 into my calculator. And then notice how this right here, this is a negative number. So really you're going to do $100. And then you're here, actually I'll erase this. You're going to do, I'll just write it big right over here, $100, and then you're taking away $34.57 from that. But in a way, you can also think of this as just the same. Every subtraction problem can really be considered as an addition problem. Sorry for swearing at you, but $34.57. This is like saying, okay, $100 plus a negative $34.57. Every expense can be considered a negative number. So if I just did this in my calculator, $100 and a negative $34.57, I am left with a positive. Left right here with a positive $65.43. Now the next one, this is a positive number. So from here, I'm going to take that $65.43 and combine with another positive number, another positive rational number, $875.50. And now I'm going to be left with a balance of $940.93. I want you to continue down on your own using a calculator until you reach the very bottom. And once you get to the very bottom, there's two questions I want you to consider. Okay. Your first question is, how can you use what you know about subtracting integers to subtract rational numbers? And give two real-life examples of subtracting rational numbers that are not integers. So where in the real world are you going to see a use of use of rational numbers subtracting rational numbers in the real world?